All right, hello everyone. The plan for the recording is to talk through factoring, and more specifically, talk through the factoring worksheet. Before I get to the factoring worksheet, I just want to, for those who are completely lost, take probably 3 minutes and just talk through how to multiply and where I'm getting my rules for how to factor. If you don't know how to go forward, multiply, you can't go backwards, which is factoring. Okay? So let's get rolling. If you understand this whole part and just want to see answers, just kind of cruise ahead, just fast forward. But if you are struggling or you're not quite sure where my rules are coming from, just bear with me for 3 minutes and listen to this. Okay, here we go. So let's just talk through our factoring. I'm not going to use a box technique. I'm going to do double distributive, which is also FOIL. They're the exact same technique, just worded a little different, but they're the same technique. Okay, I'm going to take this x value and going to distribute it to this parentheses. What does distribute mean? Multiply it by everything in that parentheses. So I'm multiplying x times x. X times x is x squared. Multiplying x times a positive 3, and I get a positive 3x. I've distributed the x to both terms. Go to the 2. Multiply the 2 times the x. And multiply the 2 times the 3. Distribute it to both of the terms in the other parentheses. Okay, combine like terms. Most of the time my like terms are right here, and that's where they're at. And I get x squared plus 5x plus 6. We're going to come back and do some summaries here in a second. Bear with me on the multiplication. I'm going to go faster and faster because I'm assuming you know what you're doing. X times x is x squared. X times a negative 2 is a negative 2x. Doing the exact same technique. X times x, x times a negative 2. Negative 5 times x, negative 5 times a negative 2. Combine like terms, and I get x squared minus 7x plus 10. Let's summarize real quick. When this sign is a positive, these two signs were the same. Positive 10, signs are the same, both negative. Positive 6, signs are the same, both positive. Okay? When the signs are the same here, the signs will be the same in my like terms. Go back to pre-algebra. When two numbers, integers, have the same sign, you add them together. 3 plus 2 is 5, and it's both positive, so it's positive 5. 2 plus 5 is 7, and they're both negative, so my answer is a negative 7. When two numbers have the same sign, you're going to add the numbers together. That was a huge summary. Hopefully you caught that. Next thing. FOIL, x times x, or distribute twice. X times x is x squared plus 9x minus 4x minus 36. And we did it enough up here. I'm assuming you can follow those steps. Combine like terms. X squared is just x squared, positive 9, negative 4. My signs are different. Go back to pre-algebra. When the signs are different, I'm adding two integers together, I actually subtract their numbers. 9 minus 4 is a positive 5x. Why is it positive? Because my 9 is bigger than my 4. 9 minus 4 is 5. I take the sign of the larger number. That was big. Hopefully we got that. Multiply x times x is x squared. X times a positive 2 is a positive 2x. Negative 7 times x is a negative 7x. Negative 7 times a positive 2 is a negative 14. Combine like terms. My like terms are right here. It says positive 2 minus 7. Back to algebra or pre-algebra. I don't do that. I don't go 2 minus 7. I go 7 minus 2. And 7 minus 2 is 5, once again. But now my larger number is negative, so it's going to be a negative 5x. I take the sign of the larger number after I subtract. Okay, let's summarize. When this sign is negative, the last term, the term that doesn't have an x, when that sign is negative, these two signs will be different. And when these two signs are different, my like terms signs are different. And when I combine like terms that are different, I actually will subtract them. So 9 minus 4 gives me a 5. I take the sign of the larger. 7 minus 2 is 5. Take the sign of the larger. Okay, that is crucial. If you don't understand this, my way of explaining things is not going to make sense. Okay. I hate to say this, but kind of ignore what I just said. All that stuff I just said, that's going to be used down here. Okay, so maybe I should have waited and done that later, but we'll come back to that here in a second. So factor completely. First question, always when you're factoring, is there a factor that's common? More precisely, is there a greatest common factor that you can factor out of both terms? So is there something that divides evenly into 3 and 12, also called a factor? Yes, 3 divides evenly into both 12 and 3. Is there an x? Is there a variable in both terms? The same variable in both terms? Yes, there's an x. Are there two x's, or is there an x squared in both terms? Yes. Now, there's two ways of thinking about this. X cubed can be written as x times x times x. X squared can be written as x times x. Is there an x squared here? Yeah, right there. Is there an x squared here? Yeah, right there. So the largest factor I can take out is the smallest exponent. Here's another way of looking at it. X cubed can be written as x squared times another x. So is there an x squared in both? Yep, right there and right there. Okay, hope that didn't confuse you, but I think it's important for some of you to see that. I'm not going to do that. You might want to see that. Okay, so if I factor out an x squared, 3 divided by 3 is 1. I had an x squared, I factored it out, there's an x left. Or I had an x squared, I factored it out, there's an x left. So there's an x here. Another way of saying it is you're dividing it out, but sometimes we haven't talked about dividing with exponents. So this, I think, is the easiest way of seeing that. Okay, 12 divided by 3 is 4. I had an x squared, but I factored it out, so all of these are gone. So what's left? No x's, just like that. Let's just double check. Distribute this out. So notice how back here we double distributed. I took x times both and 5 times both. I just have one parentheses, so I'm just going to multiply 3x squared times x, and I get this. 3x squared times 4, and I get this. Good to go. Okay. Hopefully you've done the worksheet and you are just checking your work, but if you've not done the worksheet, if you were like stuck and you had no idea what to do, now hit pause and give the question 2 a try. Based upon what I just said, hopefully you can get a little further. But if you didn't get this and you're still completely lost, at least try something. Okay, factor out your common term, see how far you can get, and then just check your logic. If you don't ever try it on your own, you'll never get better. Try it on your own. Hit pause and try it. Okay, hopefully you're back. What is evenly divides into both? What is a factor of 10 and 25? 5. Is there an x in both terms? Yep. Is there an x squared in both terms? No, there's only one x here, so I can't take out more than 1. 10 divided by 5 is 2. I had 2 x's, I took 1 away, there's still 1 left. I had 2 x's, I took 1 out, there's still 1 left. Do you see the 2 x's I have when I distribute? Okay, hopefully. 25 divided by 5 is 5. I had an x, but I took it out. It's sitting right there, so I don't need another one inside. Multiply out just to check your work. 5 times 2 is 10. X times x is x squared. Good. 5 times 5 is 25, and the x goes along for the ride. Okay. Hopefully that went better. If you still have a blank paper, hit pause and try this problem. Okay, what goes into both these two terms? 4. There is an a squared here, so I can take at least an a squared out, and there's an a squared in here. Can I take an a cubed out? No, because this is only a 2, so I can't take more than the smallest number. 12 divided by 4 is 3. A squared divided by a squared is 1. Or I had a squared, I took it out, so there's nothing left inside. 20 divided by 4 is 5. 3 a's, I took 2 away, there's 1 left inside. Distribute that out, you should get what we started with. Okay, I did pick up the pace a little bit at the end, but hopefully that's because we're getting better. Question 4. Is there something common in all of the terms? You have to ask that question first before you start thinking, oh, this looks like what we talked about earlier. I'm going to do 2 parentheses. Is there something common in all 3 terms? Yes. There is a 2 that's divisible, or these are all divisible by 2. So I'm going to factor out a 2. Can I take an x out of all these? No. There's an x here and here, but not here. Is there an x in all of them? No. Okay. 4 divided by 2 is 2. I did not factor out any x's, so there's still an x squared sitting here. 10 divided by 2 is 5. X, didn't take anything out. 8 divided by 2 is 4. Now, we didn't talk about much. In my class, we did talk a little bit about this, how to do this. But since there's a coefficient of 2, you're probably pretty safe this doesn't factor any more, and it doesn't. And I'm not going to go into that here right now. That's as far as you can go. Okay? All right. The last question on the review, question 13. No, question 15. I'll talk more about that. Okay, question 5. Is there something common in all 3 terms? Yes, a 3. 3x squared divided by 3 is x squared. 12 divided by 3 is 4. 9 divided by 3 is 3. Factor a 3. Divide a 3 out of all of these. Okay, here we go. Here's how I teach it. Let's go back to, I need to get this expression here. So let's do one term at a time. How do I get x squared? Notice back from here. Where did this x squared come from? It came from the first term being multiplied by the first term. So, down to here. How do I get x squared? X times x. Next question. This is going to be a bummer back and forth, but sorry. Stay with me for a little bit. So where did the 6 come from? It came from this term times this term. That's where the 6 comes from. So whatever I put here and here must multiply together to give me 3. What are my options? Well, this one's easy. 1 and 3. That's it. Remember before, if this is positive, my like terms, if this is positive, my like terms will be the same. And if my like terms are the same, I add the numbers together. 2 plus 5 is 7. Yes, I get it. They're both negative, but I still added 2 and 5. 3 plus 2 is 5. I added them together. I need to get a 4. So if I put a 3 here and a 1 here, my like terms will be 3x and 1x. Does that give me 4x? Yes. 3 plus 1 is 4. So my answer is x3, x1, but I have to figure out what sign goes here. Also notice, if this sign is positive, these two signs are the same. If these two signs are the same, I have to match the middle number. So the sign of the middle number is negative. So these two signs have to be negative. And we're done. X times x is x squared. Minus 1x minus 3x gives me a negative 4x plus 3. Okay, it'll go faster. For those of you who are just wanting me to do the answers, just fast forward me. Play me on 1.5, 1.7, I don't care. Okay, but don't do that if you don't understand. Okay, let's talk through this again. So how do you get x squared? First question, is there something common in all 3 terms? Nope. Okay, so now we're moving on. How do I get x squared? X and x. How do I get 20? 1 times 20, 2 times 10, 3, nope, 4 times 5. If you don't know your times tables, just go 20 divided by 1, 20 divided by 2, 20 divided by 3, and just keep going until you find them all. You don't have to go past 10 because once you get 10, you're repeating. Well, you really don't have to go past 5, but all right. So how do I get 20? I get, now, sorry, this is how I get 20. Now, this sign is negative. Remember, this is the last time I go back. Remember, when it's negative, these signs are different. And when these signs are different, my like terms are different, and I subtract the numbers. So what factors of 20 will subtract to give me 8? Why am I subtracting? Because that's negative. And if that's negative, these signs will have different, these numbers will have different signs. 20 minus 1, is that 8? No. 10 minus 2, is that 8? Yes. My two numbers are 10 and 2. I want a negative 8. Remember what I said? Sorry, I have to go back again. Remember what I said? You take the sign of the larger number. If this is a negative 7 and 2, when I subtract them, I take the sign of the larger number. So this has to be a negative larger number because this is negative. So the 10 is negative and the 2 is positive. When you do these, know why you're doing it. Why did I make the 10 negative? Because I need a negative 8. Why are these signs different? Because a negative times a positive is a negative. The only way to get a negative is if your signs are different that you're multiplying. And if my signs are different, I subtract to get the middle number. It is crucial that you understand this so that you know why all this factoring works. All right, sorry, got a little excited there. What number evenly divides into both of these, or all three of these? A 2. X squared minus 5x minus 7. 2 parentheses. How do I get x squared? X and x. How do I get 7? 1 and 7. These are my only factors. Does 7 minus 1, I'm subtracting, right? This is negative. So I'm subtracting the 7 and the 1 to get 5. Is 7 minus 1 5? Nope. Well, there's nothing else to try. It has to be. No, it doesn't have to be. You're done. 7 minus 1 doesn't work. You're done. It does not factor any further. Don't say it doesn't factor. It does factor. 2 came out of all three of them. It just doesn't factor any further. Okay. Try this one. Anything common in all three terms? Nope. How do I get x squared? X and x. Factors of 20. 1 and 20. 2 and 10. 4 and 5. This is now a positive. On this problem, it was a negative. Whoops. It was a negative. And so I subtracted to get 8. Now I'm adding to get 12 because this is positive, so my like terms will have the same sign. So what numbers work? Same, 10 and 2. But now they're both positive so that I get a positive 20 and so that I get a positive 12. 2 times 10 is 20. 2 plus 10 is 12. Okay, anything common in all three terms? Nope. So I get x and x. How do I get 24? 1 and 24. 2 and 12. 3 and 8. 4 and 6. Which one adds to give me, whoops, well, I clicked a button. Which one adds to give me 11? No, no, yes. 3 and 8. If this sign is positive, these two signs are the same. If this sign is positive, these two signs are the same. Negative times a negative is a positive. And if this is a negative, then these are both negative. Okay. Question 10. Factor and solve. So now we're going back to 7.1. How do I solve when two things are multiplied together to get 0? The only way two things will multiply together to give me 0 is if one of them is 0. Hopefully you see that this is one term and this is a second term. The only way to get 0 is if one of them is 0. Which one? Either one. So that's why we have two answers. So first question, 3 times what is 0? Well, that's easy. X equals 0. Now this one's a little harder. So when will 5x minus 7 equal 0? Just solve that equation. Add 7 to both sides. So 5x equals 7. Divide by 5, and x equals 7 divided by 5. I don't need a decimal. I don't want a decimal. Leave it as a fraction. Improper is fine. You don't have to go to mix. Unless your teacher tells you to. Okay. This says factor and solved. This one was already factored. So factor this. Make it look like that. We just did a whole bunch of them up here, right? We just did those exact same type. Hit pause. Give it a try if you have not done so already. Okay. What evenly factors into? What is a factor of 12 and 16? 4. Is there an x in both? Yep. 12 divided by 4 is 3. I had 2 x's. I took 1 out. I have an x left. 16 divided by 4 is 4. I had an x, but I factored it out. 4 times what is 0? That'd be a 0. When will 3x minus 4 equal 0? When x equals 4 over 3. And if you need to solve, go back and solve that equation. Add 4 to both sides, divide by 3, you get 4 over 3. Okay, I got to hit pause. The bell's about to ring and I'll come back. All right. If you are not done with the worksheet, I would definitely hit pause and see how far you can get on your own, and then come back and watch the recording. Okay, let's just keep rolling. First question, is there something common in all 3 terms? Answer, nope. So just factor. What 2 things multiply together to give me x squared? What are my factors of 27? I highly encourage you to write them down until you've done this 100 times and you know them off the top of your head and you don't have to write them down. Okay, get to the point where you're doing them correctly over and over and over, and then you can see them so much better when you can see them right there. Okay, questions. How do you get x squared? X and x. How do I get 27? Those two options. Since this is negative, I'm going to subtract to get 6. Which factor subtracts to get 6? 3 and 9. I want a positive 6. These signs are different. If this is a negative, these signs are different, right? Going back to here. If these signs are negative, these signs are different. If these signs are different, I subtract and take the sign of the larger number. These signs must be different. I take the sign of the larger number and make it positive. Why? Because I want a positive. And when I subtract, the larger number needs to be the one I want. Okay. Solve. This one's a little easier. X minus 3 needs to equal 0, right? Remember what we just said over here. These 2 numbers, one of them has to be 0. These are my 2 numbers. One of them has to be 0. So what value for x makes x minus 3 0? When x is 3. Why? Because 3 minus 3 is 0. What value for x makes that 0? X equals a negative 9. Okay. Sorry if these last few minutes have been kind of scattered. I've been, it's after school now and I have students coming in and different things going on. So it's been a little disjointed. Anyways, all right, let's try the last 3. I can't even remember if I finished question 12. I just came back from about an hour break. Right, I'm gonna jump into 13. I assume question 12 was done. First question, factoring. Is there something common in all 3 terms? Can I factor something out? Answer, yes. There's a 2 common in all three terms, so I'm going to factor out the 2. First question, is there something common in all three terms? If so, factor it out. Next question, can I factor this? Don't know. Let's try. So looking at 2 parentheses, how do I get x squared? Goes in the first position. Factors of 6. 1 and 6. 2 and 3. We got to be careful here. And depending upon your answer, will determine whether you understand the thought process. 6 minus 1 is 5. 2 plus 3 is 5. So the question now then is, am I adding my factors to get the middle term, or am I subtracting my factors to get the middle term? Where do I look to make that decision? Remember back here. Whoops, too far back. Remember back here. If this sign is positive, if this sign is positive, these two numbers will be the same sign. These two will have the same sign. And if these are the same sign, then when I combine my like terms, I'm adding them together. If this term is negative, then these two numbers will have a different sign, which means these two numbers will have a different sign. And I will be subtracting my two numbers when I combine like terms. So back to my question. Do I add the 1 and the 6? Or do I subtract the 1 and the 6 to get the 5? If this is positive, I have to add these together. So 1 plus 6 would be 7, not 5. So it's not the 1 and the 6. It's the 2 and the 3. They have to have the same sign since that's positive, and whatever's here, that will be the sign. If you understood that, you understand how to factor. Okay, what makes x minus 2 0? What value for x do I need to put right here so that when I subtract 2, I get 0? Or write a little equation. When will x minus 2 equal 0? Answer, when x is 2. So one answer when x is 2. Why? Because 2 minus 2 is 0. And I don't care what's here. It's not going to be 0, and this isn't 0, but it doesn't matter because this factor is 0. And 2 times 0 times something is still 0. Okay, what value for x will make that 0? A positive 3. So if x is 3, this will be 0. If x is 2, this will be 0. And when you multiply, they're going to be 0. Just got to clarify this. I'm not saying I'm plugging in 3 for this x, I'm plugging in 2 for this x. I'm not saying that. I'm saying I'm plugging in 3 for this x, plugging in 3 for this x, and I'm just going to go ahead and do it just because I want to make sure we understand that concept. And if you understand, you can fast forward it. When I plug in 3 for this expression, I get 0 here, I get 1 here, and I get 2 here. 2 times 1 is 2, times 0 is 0. It doesn't matter the fact that I plugged in 3 here and didn't get 0. I got 0 here, so it works. Same logic here. When I plug in 2, I get 0, and if any of these numbers are 0, my answer will be 0. Okay, going over to here. Anything common in all three terms? Nope. How do I get x squared? X and x. How do I get 40? Lots of options. As I do them, I'm going to ask you the question, is it right? Is 1 plus 40 going to give me 13? Nope. Is 2 plus 20 going to give me 13? Nope. Is 4 plus 10 going to give me 13? Oh, close, but nope. Is 5 plus 8 going to give me 13? Yep. Plus 5, plus 8. Get rid of that. What value for x makes that factor 0? That'd be a negative 5. What value for x makes that value, or that factor 0? That'd be a negative 8. Those are my answers. Okay, this one's a little harder. Not going to spend a lot of time, but just a little bit. Is there something common in all three terms? Nope. So this is a different kind where you have a coefficient of x squared that does not factor out. So remember the question here. How do I get x squared? X and x. How do I get 3x squared? 3x and x. If we know how to factor this, we know the questions to ask for this. It's just a little more guessing and checking, but the questions are still the same. So next thing, how do I get 6? 1 and 6, 2 and 3. Just like we've been doing on all these problems, same as this back here, same concept. But when I multiplied this together and got 8x, and I multiplied this together and I got 5x, right? When we multiplied this together and got 2x, and this gives me 3x, and I add them together to get the middle terms. So whatever I put over here gets multiplied by 3. Whatever I put here gets multiplied by x. So I'm just going to truly guess and check. Okay, the more you do these, the more you're not actually guessing. You're educated guessing, but I'm just going to truly guess. Is it 1 and 6? Well, not totally guess because I know it's going to be one of those combinations. I'm going to put a 1 here and a 6 here. 3 times 6 is 18. So I get 18x. If I'm foiling this out, I get 18x. 1 times x is 1x. Is 18 plus 1, 11? Nope. So too small. So the 1 and the 6 doesn't work. So get rid of them. And in this case, the order matters. I'm going to switch the order. I'm going to put a 6 here and a 1 here. And I get 3 plus 6. 3 times 1 is 3. 6 times 1 is 6. 3 plus 6, not 11. Switch the order. Oh, sorry, I already switched the order. The 6 and 1 don't work. That's gone. Try 2 and 3. Put a 2 here and a 3 here. I get 9 plus 2 is 9. Why am I adding? Why am I adding 9 and 2? Oh, yeah, that's positive, so I'm adding, right? So you have to know the rules. You have to know whether you're adding or subtracting and why you're adding or subtracting. 9 plus 2, oh, that does give me 11. I need a positive 11. If this is positive, both these signs are the same, and it's whatever's here. So the only difference between a leading coefficient is there's just a little bit more guessing and checking. But if you know the rules and you know the questions to ask, just go through the guessing and checking process. And again, the more you do this, the more you're not truly guessing. It'll be a little more educated guessing. And there is my answer. All right. Hope that helps. The next time you're in class, we're going to take a quiz, unless you're watching this later down the road, but we have a quiz coming back after our 4-5-day break. Oh, sorry, I didn't finish. What makes this 0? What makes this 0? This is 0 when x equals a negative 3. That's pretty easy. And I solved that equation. When will 3x plus 2 equal 0? And it's when x equals a negative 2 over 3. Just solve that thing. And those are my two answers. Okay, there you go. Hope that helps. It wasn't too long, 33 minutes. A little bit longer when you did some pausing and stuff, but all right, good luck. Good luck.